The standard reduction potentials of half reactions are given below. We have different half reactions. Along with that, standard reduction potentials are given. And on the basis of that, you have to choose the strongest oxidizing and reducing agent respectively. So in this particular question, we have to consider the reduction potentials. And one thing I just want to tell you, that when we talk about the standard reduction potential, the standard reduction potential basically make clear about the oxidizing power of the substance. It means if the substance has more standard reduction potential, its oxidizing power would be more. So we have to just check which has the maximum standard reduction potential and which one has the least reduction potential. So let's check. If you look at the given half reactions, you will identify that cobalt CO3 plus ion, that is gaining electron to form CO2 plus ion, and standard reduction potential for this is plus 1.81 volt. That is the maximum one in this category. While if we talk about the least, that is least for lithium ion, and in this case it is minus 3.05, the least value. Which is the strongest oxidizing agent? That strongest oxidizing agent is, I'll just write here, strongest oxidizing agent, that would be cobalt 3 plus. And if we talk about the strongest reducing agent, that would be that substance which has the least standard reduction potential. So which species is there? That is Li plus ion. So this would be the answer. So where these are given? These are given in option 2. So I'll choose this as the correct answer. After this, there's a turn for question number 57. Now question number 57. The electrode potentials of the following half cell reactions are. We have two different half cell reaction. Magnesium is getting changed into Mg2 plus ion, and in this case 2 electrons are removed. This is the process of oxidation. Further, there's the process of oxidation also. Silver is getting changed into Ag positive ion, and there is its electrode potential that's also given, 0.80 volt, that's given. The E standard for the cell reaction, that is Mg plus 2Ag plus, is giving you Mg2 plus and 2Ag. In this case, we have the two different half reactions. Those are given, and we know that E naught cell, if you want to find out, that is equal to E cathode minus E, and we know that in this particular cell, substance that you are taking at anode is silver, and that is taking part in reduction process, and it will be written as this way. It would minus be Mg2 positive, it's getting changed into Mg. This would be this value, this Ag positive to Ag. So if you check here, this is conversion of Ag to Ag plus. So this value becomes positive 0.80 volt minus. If we talk about this process, here is the process that's given. Mg is getting changed into Mg2 plus. So for this process, it becomes minus 2.36. So if you solve this, you will find out this value is 3.16 volt. And on that basis, the correct answer is option 1. I hope this question is clear to you. Let's take next question. Question number 58. If 0.2 molar aqueous solution of a monobasic weak acid is 40% dissociated, then the freezing point of the solution will be. Kf value of water is given, that is 1.86 Kelvin kg per mole. In this case, alpha value is also given, that is 40%, or you can say it is 0.4. The alpha value is 0.4. I is calculated. I can be calculated with the help of this alpha value. We know that alpha is equals to I minus 1 upon N minus 1 for the process of dissociation. So in this case, we have this alpha, that is 0.4. I we want to calculate. upon n minus 1. So if we talk about monobasic acid, the number of particles would be 2. It would be 2 minus 1. So this value I is equal to 1 plus 0.4, and that is 1.4. So I value we have. Now we have molality, that is 0.2 molar, and now we just want to find out the freezing point of the solution will be. We know that delta TF is equal to KF M, and this is dissociating, that's why I would also be there. So this is equal to 1.4 into KF value, that is 1.86. And what is the molality? That is 0.2 that I'm taking here. And if you multiply this, then you will find out that this delta TF value is equal to 0.52. This is delta TF. Now the question is, what is the freezing point of the solution after mixing? So we know that if pure water is there, the freezing point would be 0 degrees Celsius. So definitely the freezing point of solution would be equal to 0 minus 0.52. So it would be equal to minus 0.52. Where it is given? This is in degrees Celsius. So where this is given? It is given here in option 2. So this is my correct answer. Now, after this, let's say question number 59. Which among the following aqueous solutions will boil at lowest temperature? It means which has the lowest boiling point you have to identify. We have 0.1 molar AgNO3, 0.1 molar sucrose, then we have 0.1 molar acetic acid and 0.1 molar calcium chloride. We should know that lower is the I factor for the given solutes. Definitely lower would be the boiling point. So we have to just check here what is the I value. So lower the I value, lower will be the boiling point of the solution. Now, for AgNO3, dissociation would be there. So, in the given species, if you check, this sucrose is the non-electrolyte. And if it is the non-electrolyte, it will not dissociate. And for this I value is 1. That would be the lowest in all of these cases, because in case of CaCl2, this I value would be more than 1. That would be 3. For the CH3COOH, there would be some I value. For AgNO3, I value would also be there. But in case of sucrose, this I value is 1. And that will result in its lowest boiling point. So definitely, this is our correct answer. And I'll choose it as the correct one also. Now, after this, there's question number 60. The vacant space in FCC unit cell is, if we talk about this FCC unit cell, we have to find out the vacant space. With the help of packing efficiency, you can do that. In case of FCC or HCP, the packing efficiency we all know that it is approximately 74%. It means this much part of that crystal is packed. But if we talk about the vacant space, the percentage vacant space is equal to 100 minus 74. So this would be 26%. So the percentage of the vacant space is 26%, and that's given here in option 3, and that's my correct answer also. Now, after this, let's check the next question. That's question number 61.